Hello everyone, welcome back to Malik034 channel. This is Mallikarjun. In this today's topic, I'm gonna basically talk about the RAC database specific background processes, where these background processes plays a very important role when it comes to the database, the RAC database core functionalities, like the synchronization between the nodes and the data reliability between the cluster nodes, and how the data consistency is managed across the cluster nodes. So everything to make this rack setup. So these rack background processes are plays a very important role. So one has to understand these background processes in detail, and they should be very clear on these background processes in order to be strong foundation in your rack database or rack DB knowledge. Right, so these rack, the rack specific background processes are plays very important role, right? So we will get in detail with all each and every background processes related to rack. So in detail we'll go through that all the background processes. So each and everyone knows that there are many a number of background processes related to database, related to ASM, and related to user process, and related to server process. So there are so many background processes, but we are not going to concentrate on all those. Our areas of focus area, our area of intention is just to look into rack background processes. So before I get started with this today's technical discussion, if you are new to my channel, always go back to YouTube and search for Malik034. Please do subscribe. If you like my videos, please don't forget to give a thumbs up, and please share with your friends and colleagues. And if in case if you missed out my previous session, you can always refer it in my YouTube channel Malik034. Right, so let's get started with the today's session. So just to recap, as I said, there will be n number of processes related to database, related to ASM, and related to your server process, related to user process, and related to your, there are n number of processes, I can say, right? So we are not going to concentrate on the database background processes like DB writer, checkpoint, log writer, PMON. We are not going to concentrate on that, and also we are not going to look into the grid infrastructure or ASM specific background process. That also we are not going to check it out. Our area is focus area is rack specific background processes. If you can see, these are like ASM background processes like RBAL, ARBN, GMON, MARC, ONNN, and PZ9N. These are like specific to ASM background processes, but I'm not going to cover it in this today's session because today's session is specific to rack background process. These are like ASM specific background processes, and the checkpoint, log writer, SMON, or these are related to my database or instance specific background processes. And in case if it comes to the rack configuration, so how the cluster node communication happens and how the cluster synchronization will happens. So to manage all the rack setup, so there will be set of background processes. So those are like we can call it as rack specific background processes. So if you can see this particular slide here, I have listed out the major background processes related to rack. ACMS, atomic control file memory service, GTX 0 to J, it means it's 0 to 9 and A to J. So these are like global transaction processes. And LMON, global Enqueue service monitor, LMD, global Enqueue service daemon, LMS, global cache service processes, LCK, instance Enqueue processes, and DIAG, diagnostic daemon, RMSn, rack management processes, RSMN, remote slave monitor, DBRM, database resource manager, starting from 11gr2, and ping, resource time agent, from again it is also starting from 11gr2, and LMHB, the global cache or Enqueue service or heartbeat monitor, RCBG, the result cache background processes, right? So we are gonna deep dive into each of these processes. But if any interview question, if they ask what are the rack specific background processes, you should be able to answer. These are the rack specific background. So you should be able to answer this question. And then these are the two Oracle MOS documents. You can search it in Google. So these two talks about RAC specific background processes. So this contains much more information. I'll show you these two URL later. So let's start with the deep discussion on these all the RAC background processes. As I said, ACMS atomic control file to memory service, ACMS starting from 11G. So what exactly this background process does? If you read this particular line here, it coordinates consistent update to the control file resource with its SGA counterpart on all the instances in an Oracle RAC environment. Yeah, as you see, like in the RAC database we'll be having a multiple instances. So in case if two or three instances trying to update my control file, and then what guarantee and what consistency I can manage. For that, ACMS will comes into picture. ACMS will handles all this consistent update from all the database, all the rack or cluster instances to the control file, because we'll be having only one, or if it is a multiplex it will be having two or three control files that is shared across all the cluster instances. So in case of any consistent update to the cluster control file, ACMS comes into picture. In an Oracle RAC environment, ACMS per instance processes is an agent that contribute to the ensuring distributed SGA memory update is either globally committed on success or globally aborted if it is a failure, right? So the in simple words, if there is a consistent update from the multiple instances in my rack or in my clusterware, so this ACMS will comes into picture to handle that particular update to my control file, right? So that's about ACMS. And if I can talk about GTX0 to J, it's a global transaction process starting from again 11G, where N is GTX N, I can say, where N is 0 to 9 and A to J. You can say GTX 0, 1, 2, 3 up to 9 and A, B, C up to J. These many number of processes, it will be it is regarding this GTX0J global transaction process. What this process basically talks, this GTX process provides the transparent support for XA global transaction. What that XA global transaction? XA global transaction means that is your distributed transaction. If you can see a distributed transaction to span multiple rack instances. If you submit any DML, DDL or any query, and that query should be is going to distribute across my all cluster nodes. So that is gonna managed by my global transaction process. So GTX process provides a transparent support for XA global transaction in rack environment. The database auto tunes the number of these processes based on the workload of XA global transactions. So it's everything is managed by this GTX. If it's a distributed transaction, so it will manage it on which all instance I can span my threads, and how much load I can spread across all these nodes. Everything will be controlled by my GTX0. And the particular the initialization parameter is global transaction underscore processes. This is a parameter you can set it for this particular background processes. By default it will be 0, and you can set it by setting this particular parameter. And LMON is a global Enqueue service monitor. What that global Enqueue service monitor basically does is monitors an Oracle RAC cluster to manage a global resource. That means LMON maintains instance membership within Oracle RAC. The process detects instance transition and performs the reconfiguration of GES and GCS resource. So if you read this particular line here, the LMON process monitor global enqueues and resource across the cluster and perform the global enqueue resource operation. So if you are aware of this GRD, right? GRD is the one where basically manage all my block information, which instance has which latest block, everything will be managed with GRD. So to that GRD to properly handle this GCS and GES, global enqueue service and global cache service. These are the two background processes plays very important role, and to hold a specific the logs on that particular blocks or particular row or a particular table. So GCS, global enqueue service, plays very important, and to monitor that particular logs, this LMON, global enqueue service monitor, this LMONs plays major role to monitor my GES, the global enqueue services. Whenever there's a clusterware logs, that all the logs, everything will be managed with this LMON. LMON, if in a simple words, LMON will basically monitors my enqueue services. Enqueue service is nothing but my GES, which is global enqueue services. So that global enqueue services will holds that enqueue services knows which instance holds which resource, and which resource belongs to which instance, and where is the latest information of a particular block, which instance is holding that particular block. All the information will be provided, will be known using this GES process. How this GES process knows about that? GES process will read my GRD table and it will get that information. So all this monitoring process will be done by this LMON. Now, going to the next background processes, LMD, global enqueue service daemon. What this LMD does, if you read this one, the LMD process manages incoming remote resource request within each instance. It is like incoming request. Whenever there is incoming request for a particular block or a particular resource, that request will be managed using this LMD. That belongs to each instance wise. So if you instance 1 is requesting for that particular block, so LMD will come into picture. And again, if you go to instance 2, again there is a one more request comes for any particular block, again that LMD belongs to that particular second instance will comes into picture, and that will provides the necessary information. Again, manages incoming remote resource request from the other instance. That means, if I have an instance A and instance A has a block A, I can say, and then instance 2 needs that block A, and the request from the instance 2 will goes to instance A. So that request, the remote request between the instances, will be managed using LMD. LMD processes enqueues resource managed under the global enqueue service. In particular, LMD 0 processes incoming enqueue requests and enqueue request messages and controls the access to the global enqueues. And it also performs the distributed deadlock detection. So in simple words, if I can say this LMD, if there is a block A and that belongs to instance 1, and the same block A is requested from instance 2, and then this LMD will make sure that there's a lock on that particular block or on that particular row, and then that block will be moved to the instance 2. So this is nothing but your like deadlock or locking mechanism in your RAC environment. LMD is plays very important when it comes to the remote resource request. And from the instance to instance, if there is any request for the resource or request for the block, so this LMD will come into picture. And going to the next slide, LMS, global cache service process. LMS, what LMS will do? The LMS process maintains records of a data file status and each cached block by recording the information in the GRD. Right. So if there's any particular block is modified and the latest data is updated by instance 1, and my LMS will know that my instance 1 will be having that latest block by reading this GRD table. The LMS process also controls the flow of a message to the remote instances and manages a global data block access and transmit block images between the buffer cache of a different instances. This process is a part of cache fusion, right? So LMS is nothing but LMS is smart enough to know which instance holds which data block. How it knows? By reading my GRD table. And also LMS will play very important role in transmitting the blocks between the one instance to the other instance. So because without reading your LMS, without help of LMS, the remote instance cannot get the block from the other instances. So this mechanism we already discussed, cache fusion, the block transmission between the buffer cache in a rack environment and the clusterware is called cache fusion. So LMS is closely coordinates with this cache fusion. This cache fusion is a mechanism or a technique where the data block will be transferred between the buffer cache of each cluster nodes whenever there is a requirement of that particular block. So everything we discussed in our last session about this cache fusion, right? Though I believe this LMS is closely working with my cache fusion. So manages resources and provides a resource control among the Oracle RAC instances, right? So whenever there's there's a particular block needed, so LMS comes into picture and it will look for that GRD table, and if it is already available in any of one instance, and it will directly transfer that block from that buffer cache to other instance. LMS where LMS it basically spans 0 to 9 and A to Z. These many processes you can have it. Maintains a block database, global cache service, and buffer cache resources. This process receives, processes, and sends GCS requests and block transfer and other GCS related messages. So this LMS plays very important, and it plays multiple tasks like no processes, and it receives and it processes and it sends the request and it transmits the block. So many processes LMS will play very important role when it comes to the clusterware. And LCK0 instance Enqueue process. Instance Enqueue process is nothing but what you can say in standalone database like lock or latch mechanism, right? So if you can read this particular line, the LCK process manages non-cache fusion resource requests such as library or row cache request, manages global Enqueue request and cross instance broadcast. The process handles all the requests for a resource other than data block. For example, LCK0 manages library and row cache techniques. So what that LCK basically talks about, non-cache fusion. The cache fusion is nothing but the transmitting the data from the buffer cache of one instance to the buffer cache of other instance. If it comes to the data block, it is a cache fusion that is being managed by LMS. And if it comes to the non-data block related information like such as libraries or row cache request or any other dictionary related information, so everything will be managed by LCK. So just a difference between LMS and LCK. LMS is for my cache fusion, transmitting the data block from one instance cache to other instance cache, and LCK is transmitting the data from one instance to other instance, which is not a data block, that is library or a row cache or any dictionary object, right? So if I go to the next, DIAG, everyone knows that diagnostic DIAG tool, like diagnostic tool, DIAG diagnostic Daemon or diagnostic process, diagnosability process, anything you can call. DIAG performs diagnostic dumps. What that diagnostic dump means? Performs diagnostic dump requested by the other processes and dumps triggered by the process or instance termination. In a Oracle RAC, DIAG performs global diagnostic dumps requested by the remote instances. If node 1 goes down, node 1 crashes, and the node 2 will kickstart this DIAG, and node 2 goes down, and node 1 or node 3 will kickstart the DIAG process, and it will dumps all the trace and all the logs into one particular diagnostic files. And this is basically like the monitoring background processes which will be dumped in case of any particular instance crash, or in case of instance terminated or node reboot. So this is kind of a background monitoring process. In DIAG process is also available in standalone database, in ASM, everywhere it is available. In RAC also, DIAG, Diagnosability Daemon or Diagnosability process is also one of the background process. RMSn is Oracle RAC management process. What that does? What is the significance of that? Performs manageability task for Oracle RAC. What is that manageability task? RMS process performs manageability task for Oracle RAC. Task accomplished by an RMS process includes creation of a resource related to Oracle RAC when new instance are added to cluster nodes. If suppose I have a 2 node rack or 3 node rack, if we add one more instance and this RMS comes into picture, that will, you know, that will collect, that will provides all the information needed to achieve that particular task. If you are going to add it, like creation of a resource related to the Oracle rack, what are, for example, if I have 2 node rack and both the nodes will be having my n number of resources, n number of services for my rack functionality. So the moment you add the third node, and for that third node to do a proper functionality in my clusterware, even that third node should have a bundle of like set of processes, set of services and set of resources needed for that particular third node. And which process will provide all those information, all those details? My RMS will give all those details. Whenever there's a creation, the creation of a resource related to the Oracle rack, when there's a new instance is added to my cluster nodes, right? Whenever you create a new instance or whenever you create a new node and whenever you add a new node, so this RMS process will comes into picture, and that will provide all the information, all the resources, all the services needed for that particular instance to start, instance to function properly, or that instance to add to my cluster node or my cluster service, right? RMS performs variety of tasks. What are those tasks? Creation of resource related to rack when there's a new instances are added, and managing and whatever it is, like if you create a new instance, suppose I have two instances now, and if I want to add a third instance, and I cannot simply add the third instances, I cannot create a third instance simply. So as a DBA, like I just create a single command to add my one instance, but in backend, who will provide the information to that instance to to join to my cluster and to do proper functioning and to maintain the cluster synchronization and to maintain the consistency across the nodes and to run that particular instance without any issue with my cluster other in coordination with the other cluster node. All the information for the setup, everything will be provided by my RMS. If I go to the next, RSMN, that is remote slave monitor. What that remote slave monitor does? Remote slave monitor manages background slave processes creation and the communication to the remote instances. These background slave processes performs task on behalf of a coordinator process running in another instance. So that name itself will tell, right? Like the slave monitor means if you run any distributed transactions, that transaction will go across multiple instances. Or if you run any particular processes, if that processes spam across 2 or 3 cluster nodes, if you have 4 node cluster nodes and if your processes spread across all 4 cluster nodes, how you know that whether those processes are running fine or whether your request is processing fine across all the nodes? Because you have connected to only one instance 1 you connected, and the moment you submit your request, it spread across all 4 instances. And then how that your connection on the instance 1 knows other 3 instances are processing your request or not? That basically managed by RSMN. So the moment you connect to node 1, the node 1 process is like your master process, that is coordinator, and from that node 1 it will spread your request to the other cluster node like cluster 2, 3, 4, and then this RMS process will manages on the remote node whether your request is processing fine or not. Those are like slave monitors, slave processes. And once everything is done, that process will give back all the detailed information to your the master or coordinator processes which is running on node 1. That is the concept here, distributed transactions, I can say, right? What it says, remote slave monitor manages background slave processes creation and communication on the remote instances. These background slave processes performs task on behalf of your coordinator process. That means you connect it to node 1 and node 1 is act as a coordinator, and from there it will distribute the work or distribute the transaction to the other rack instances, and this RMS process will communicate between all the cluster nodes, and it will keep monitoring the process whether they are running fine or whether they are stuck or whether they failed. Everything it will monitor, and then it will send back to the coordinator on the node 1 whatever the process you started, master process, and it will communicate, and it will update that coordinator whether the process are running fine or failed or hang or whatever it is, like it will give the all the information to the coordinator. Manages the background slave processes creation and communication on the remote instances. For example, it will communicate between all the cluster nodes, and it will say, so I'm still running, are you done? And the other instance will say, I'm also still running, are you done? Like it will be like coordination between all my cluster nodes until that all the transactions are completed on all the cluster nodes. And my coordinator will be keep running and keep coordinating with my RSMN process, and it will be keep getting the information about the remote nodes, how the processes are running. This background processes manages creation or a slave processes and communicate with their coordinator peer. That's the same thing, right? Like it will be keep communicating with a coordinator or master process, and it will be keep updating about the regular update of my status of that background process, status of that transaction, distributed transaction process. Right, coming to the next, the DBRM, database resource manager. Again, it's starting from 11G release 2. This particular the name itself, database resource manager. So database, if you want to control your resource and which instance want to use how many CPU, how many resources, how many IOs, everything can be controlled using your database resource manager. And similarly that there will be one more like IORM, IO resource manager. If you want to control your IO operation, so you have to set your profile like IO resource manager, and then you have to set a couple of parameters like how much percentage, how much IO, how much utilization, everything you can define in that IORM. Similarly, DBRM is database resource manager. You can set a profile, and you can provide a couple of parameters like I want 10% of CPU goes to instance 1, and 20% of CPU goes to instance 2, and I want I want what I can say, I want this IO 20% IO should go to this instance, and 30% IO should go to this instance, and again CPU IOs and memory, I want this 80% memory to go to one instance and 20% memory to go to other instance. Like everything you can limit, and you can build your own profile, and you can set that profile to the particular services or particular instances. So everything can be managed using your database resource manager. If you read this one, set up resource plans, you have to the plan you have to build first, and you have to test it, and you have to apply it in your production. It's a set up resource plans to perform other tasks related to database resource manager. If the resource plan is not enabled, the process is idle. So it is everyone knows that DBRM is most of the organization, DBRM is a one, like if you are having multiple applications like EBS, ERP, and PeopleSoft, and HRMS. If you are having a multiple applications running on a database, so you have to control each applications by limiting or by enabling this database resource manager plans. Right, so most of the organization DBRM will be enabled, and that will be used widely. And if I go to the next, ping, response time agent. Ping name itself will tell what that ping means. Ping, whenever if you want to ping the server, whenever you check the server is online or alive, you will always use the ping command, right? So what is the need of ping here? if you say in RAC environment, ping is very important, because how my cluster node know each other whether other cluster nodes are online or alive or not, because the node 1 in my cluster should know that other cluster nodes are online or offline, and node 2 also should know that other clusters are online or offline, and node 3 also should know other cluster nodes are online or offline. Each cluster node should be able to know the status of the other cluster nodes. Then only there's a cluster synchronization will be managed and data consistency will be managed across my cluster nodes. Without knowing that, I cannot achieve my cluster concept. I cannot achieve my cluster database, right? So if we talk multiple times about cluster interconnect, right? Cluster interconnect is a private network where each cluster communicate each other. Each cluster nodes will communicate each other in a private network. That is nothing but cluster interconnects that will be achieved using HAIP. So each cluster nodes will be pinging on every seconds or every few seconds or every 3 seconds. There's a particular time limit, you can set it. Each every 3 seconds, each every millisecond, each cluster node will be pinging each other and making sure the other cluster nodes are available or online. That is the concept of ping. The ping plays very important when it comes to the RAC setup or RAC environment. It's one of the major background, one of the important background processes in the RAC concept. Every few seconds, the process in one instance sends a message to each instance, and the message is received by the ping on the other target instances. The time for the round trip is measured and collected. If I ping, and it will go to the other nodes and it will come back the response, so that whatever the time it has taken, that time will be marked and collected. And if I can talk about the ping specifically, it is nothing but like network heartbeat and disk heartbeat, right? So we already talked more about network heartbeat and disk heartbeat. So network heartbeat is like, communicating each my cluster nodes by pinging each other, and disk heartbeat is nothing but writing my voting disk. Each cluster instance will write to my voting disk, that is a disk heartbeat. So that is nothing but that concept will come comes with the help of ping. So LMHB, a global cache Enqueue service heartbeat monitor. So monitor the heartbeat of LMON, LMD, LMS processes. LMHB monitors LMON, LMD and LMS processes, and to ensure they are running normally without blocking or without spinning. So we already know about LMON, LMD and LMS. What is LMS? Global Cache Service. What is LMON? It's a Global Enqueue Service Monitor. What is LMD? Global Enqueue Service. As we already know, these are the very mandatory background processes and must and running always. If any of these processes are hang or terminated, so your instance will go down. And for that, your LMHB plays a very important role. That is kind of a monitor which will internally monitors these background processes, LMON, LMD and LMS. And in case of these processes are not running normally, or it are blocked, or that spinning, so automatically this LMHB will raise the flag. And sometimes that will be fixed by automatically, and sometimes that needs a DB intervention and should check it out why those services are blocking, or why those are like spinning, and why those sessions are those processes are getting terminated and restarting again and again. So that all we can get it from this LMHB, right? So if I go to the next, RCBG, result cache background process. The result cache, the moment you see that result cache background process, you should know that what that background process does, right? So it handles the results of a cache messages. What are the cache messages it will handles? So basically, it records the messages like from the other instances or the cluster, what are the cluster remote nodes. Whenever there's a message, service message generated by the server process, that all the messages will be the managed, or the result will be kept together, that handled, the cache messages are handled by this RCBG. This process handling the invalidation and the other messages generated by the server process of the other instance. So this basically RCBG, result cache background processes, handles the result of a cache message. This process is used for handling invalidation and the other messages generated by the server process attached to the other instances in a Oracle DAG. For example, the other cluster nodes generate some messages, other cluster node, the server process generates some messages. Everything will be cached and everything will be clubbed together and will be managed in particular, managed by one particular background process, that is RCBG. And this that's it, I believe. Like, these are the mandatory background processes when it comes to the rack. So in my next session I'm going to show you all these background processes with my lab environment. And one of the basic important the DBA question is, what are the rack background processes? So you should be able to answer ACMS, GTX0, LMON, LMD, LMS, lock, and DIAG, RMS, RSMN, DBRM, ping, LMHB, and RCBG. So these are the mandatory and main background processes for when it comes to the Clusterware. And that's it for today's session. Let's take it to the next lab session, and I'll show you all this background process. Thank you, guys.